Welcome to the Explainer. So, have you ever wondered how scientists can look at a totally clear liquid and just instantly know if it's perfectly safe water or a really dangerous acid? Well, today, we're diving straight into the science of chemical properties to unlock that exact mystery. And we're going to do it using colorful indicators and the pH scale.
Here's our quick roadmap for today. We'll start with the hidden chemical mystery, meet our chemical detectives, learn how to make your own indicator, measure strength with something called the universal indicator, and wrap it all up by understanding the pH scale.
All right, let's jump right into Section 1, the hidden chemical mystery.
Okay, let me paint a picture for you. Imagine there are 3 glass beakers sitting right in front of you. They all contain completely clear, odorless liquids. Literally, they look absolutely identical. But you know for a fact that one is water, one's an acid, and one's an alkali. So how in the world do you tell them apart? Obviously, you can't taste them, right? And touching them, no way. That could give you a severe chemical burn if it's a strong acid or alkali. So how do we safely solve this puzzle without laying a single finger on them?
Well, the secret lies in a simple chemical indicator. An indicator is pretty much exactly what it sounds like. Think of it as a microscopic detective that reveals invisible chemical properties for us. By definition, it's a substance that turns one specific color when you put it in an acid and a totally different color when it hits an alkali. So with just a few drops of this magic liquid, those 3 identical clear beakers are going to reveal their true identities to us right before our eyes.
Which brings us to Section 2, Meet the Chemical Detectives.
Take everyday red cabbage juice, for example. It's actually amazing. It transforms from its normal, natural color to something totally new depending on what it interacts with. If we drop some red cabbage indicator into those mystery beakers we just talked about, the acid will instantly turn a bright, vivid red. The pure water, that turns a lovely shade of blue. And the alkali will turn a really distinct yellow. Just like that. Using literally just the brightly colored juices from everyday plants, we've solved our dangerous beaker mystery, instantly and safely.
Now, it's absolutely crucial to know that different indicators have different color rules. Let's look at litmus. It's a super common indicator made from a living organism, usually soaked right into absorbent paper. If we test something like hydrochloric acid, or just everyday lemon juice, litmus turns red. That's the hard and fast rule for acids. But if we test an alkali like sodium hydroxide, it turns blue. And what about pure water? Well, water is neutral. It's neither an acid nor an alkali. So in a perfectly neutral substance, litmus turns a nice shade of purple.
Let's move right along to Section 3, making your own indicator.
You know, you can actually make your own indicator solution right at home. It's super easy. First, you just take some brightly colored plant material, like red cabbage, blackcurrant, or even beetroot, and chop it up. Next, you pop those pieces into a pestle and mortar and crush them down. Then, you add a little bit of ethanol. A quick heads up here, though, you really need to read the hazard labels because ethanol is highly flammable, so definitely be careful. Anyway, you just keep crushing until that vivid color really bleeds out. Finally, grab a pipette to extract your freshly made, homemade indicator liquid. And boom, you are officially a chemical detective.
Next up is Section 4, measuring strength with the universal indicator.
So we can actually upgrade from basic litmus to what we call the universal indicator. Think of litmus kind of like a basic light switch, right? It basically just says acid or alkali. It's great for a simple yes or no. But the universal indicator, that thing is a real game changer. It's like upgrading to a high-definition, full-color monitor. Because it's actually a really specialized mixture of several different indicators, it changes into a massive spectrum of different colors. It doesn't just tell us what a substance is, it tells us exactly how acidic or how alkaline that substance truly is.
With the universal indicator, the colors give us these incredibly precise categories. For instance, if a substance is a strongly acidic chemical, the indicator turns a deep, fiery red. If it's only weakly acidic, you get a yellow. A perfectly neutral substance, that's going to turn it green. Flipping to the other side, a weakly alkaline substance will show up as a nice blue, while a strongly alkaline substance turns a really dark, vivid purple. So we've gone from just knowing a broad category to knowing its precise chemical strength.
And that perfectly sets up Section 5, understanding the pH scale.
To make sense of all these colors, scientists use this universal ruler called the pH scale. It measures the absolute strength of acids and alkalis using numbers from 0 to 14. And it is so cool how perfectly the universal indicator colors line up with this scale. Down at a pH of 1, we've got our super strong acids flashing bright red. Right dead in the middle at pH 7, we have our perfectly neutral green. And all the way up at pH 13 or 14, we see the deep purple of strong alkalis. The pH scale basically takes our colorful visual observations and assigns them an exact, undeniable number.
When we start testing everyday items with this scale, the world around us really starts to make a whole lot more sense. Let's look at a few examples. If we test lemon juice, the universal indicator turns red-orange, giving it a weekly acidic pH of 4. But interestingly, your average cola drink also turns the indicator yellow, landing right at that exact same weekly acidic pH of 4. Kind of makes you think about what you're drinking, right? Meanwhile, a standard soap solution turns blue-green, revealing it to be a weakly alkaline liquid with a pH of 8. It completely changes how you look at the basic liquids sitting in your own home.
So, based on everything we've just uncovered, let's say you tested a mystery liquid from your fridge and it had a pH of 7. What color would it turn our universal indicator? Well, you now know that a perfectly neutral pH of 7 turns it green, meaning you're probably just about to drink some safe, refreshing water. But honestly, this is just the beginning. This pH scale dictates the rules for everything around us, from the health of the soil growing our food to the delicate balance of our very own blood. So what other invisible chemical battles are happening around you right now? Keep exploring, stay curious, and I'll see you in the next explainer.